Welcome to Geometry for AP. Tonight's video we're going to discuss how to take a quadrilateral and prove that it is a parallelogram. In the night before's video we had the fact that we knew it was a parallelogram and we were just working through the properties of what a parallelogram is and what you can do with all those different properties. So please make sure you take a second to write down that right there, which is the essential question. You can decide whether a quadrilateral is a parallelogram if its sides, angles, and diagonals have certain properties, and that's what we're looking for. Okay? So, first thing I want you to do is I want you to write theorem 6-8. I want you to have this picture and this. I want you to have this theorem, this picture, and this. And so pause the video and put those down. This first one says that if both pairs of opposite angles are congruent, then you can say that quadrilateral must be a parallelogram. Next one says that if the angles of the quadrilateral are supplementary, the consecutive angles, then it must be a parallelogram. So get that one written down also with the pictures and everything. We have three more theorems. This one says that if both pairs of opposite angles are congruent, then it's a parallelogram. So this and this down, and get this one and this one. Get each of these down with all their pictures on. 6-11 says if the diagonals of the quadrilateral bisect each other, then it is a parallelogram. And then finally the last piece says if one pair of sides of a quadrilateral is both congruent and parallel, this is an interesting one. One pair of sides, one pair of opposite sides are both congruent and parallel, then it is a parallelogram. So one side is parallel and congruent. This is the one that people forget all the time. So watch out for that one. All right. So if we look here, it says, what are the values for y that must TQRS be a parallelogram? So if I look here, first of all, we can't find y yet because this y is going to be equal to this piece here. So in order to find y, I got to know what x is. And I know since this is we're trying to figure out what this is, and in order for it to be a parallelogram, these two sides would have to be congruent. So I'm going to start off by first knowing that opposite sides must be congruent. So to find x, I'm going to say 3x minus 5 equals 2x plus 1. And I'm going to solve this. And I get x is equal to 6. Then in order to prove y, I'm going to plug the x value back in. So y is equal to x plus 2, which is 6, and so I get 8. And so therefore, in order for PQRS to be a parallelogram, y must be the value of 8. Okay. So if you want to pause the video and try this one, that'd be great. Okay, for this one, it says find the values of w and z that would make this parallelogram. All right, so if I look at w are opposite angles, z is opposite angles. So we know that if this was a parallelogram, the opposite angles would have to be congruent. So to find w, I'd say 5w minus 30 is equal to 3w plus 10. And I'd solve this, and w to equal 20. To find z, I'd know that these opposite angles are congruent, and so therefore 8z minus 10 would be equal to 7z plus 5. I get z is equal to 15. So therefore, in order for this figure to be a parallelogram, w would have to be 20, and z would have to be 15. Okay, so this is where some of the tougher work comes in. So let's take a look at this problem here. For this problem, we want to prove this quadrilateral is a parallelogram by definition. Remember, the definition says that there are two pairs of parallel sides. So two pairs of parallel sides. So in order to prove parallel sides on a coordinate plane, we need to know the slope. So I need the slope of AD. I need the slope of AB. I need the slope of CB, and I need the slope of CD. So if I look at AD, it's going to be 1, 2, 3 up, and 1, 2, 3, 4, 5, 6 to the right. So 3 up, 6 to the right, so that's equal to 1/2. AB, which is going to be 6 down, and 2 to the right. So that's negative 3 over 1. CB. So that's going to be 1, 2, 3 up, and 1, 2, 4, 5, 6. So 3 up, 6 to the right, which is equal to 1/2. And then finally CD, which is going to be 1, 2, 3, 4, 5, 6 down, and 2 to the right, which is -3/1. And I can see that AD is parallel to CB, and that AB is parallel to CD. Now, just having this is not enough. You have to have all these slopes also. So you have to all this parts. So to prove a figure is a parallelogram, yeah, by definition, you have to have the slopes of each side and be able to write this statement. Got to have that work there. Okay. All right, next one says, prove this figure is a quadrilateral. This quadrilateral is a parallelogram by proving the opposite sides are congruent. So A to D, we need to know the length of AD. So AD squared is equal to 1, 2, 3, and 1, 2, 3, 4, 5, 6. 3 squared plus 6 squared. So AD squared is equal to 9 plus 36. So AD squared is equal to 45. And so AD is equal to the square root of 45, which means AD is equal to 3 square root of 5. All right, let's do the next one. We need AB. So AB squared is equal to, this is 1, 2, 3, 4, 5, 6 down and 2 over. So 6 squared plus 2 squared. So AB squared is equal to 36 plus 4. So AB squared is equal to 40. And so the AB is equal to the square root of 40, which is going to be 2 squared of 10. Okay, so to find the length of BC and CD also, we can pause the video and do those. BC squared is equal to 3 squared plus 6 squared. Well, we've already done 3 squared plus 6 squared, so we know that BC is equal to 3 squared of 5. And then we need CD squared is equal to, and that's 6 and 2, so 6 squared plus 2 squared. And we know that CD is going to be equal to what it was up above it, which is 2 squared of 10. So I can say that AD is congruent to BC, and that AB is congruent to CD. And so then I've just proven that the opposite sides are congruent. I would have to say the one we did before this had less work than this one. Next one. I'm not going to do this one for you. If you want to do this one, you may. This is the hardest way possible. First things first, you would have to find the midpoint right there. So you'd have to use the midpoint formula. Once you found the midpoint formula, you're going to have to do the distance from here to here and see that it's the same as here. And then that's 2 sets of distance from me. And then from here to here, and prove that this one is congruent to this one, and this one is congruent to this one. And so that's going to take a little bit of time. And you're going to have midpoint twice, and you're going to have distance formula 4 times. So this is the hardest way to do it. I would not recommend using this way. Okay. And so then let's look at our last little thing. So on a coordinate plane, what are the methods you can use to prove a figure is a parallelogram? All right, so let's look at this. We can prove that both pairs of opposite sides are parallel. And so that method works on a coordinate plane. Prove that both pairs of opposite sides are congruent. That works on a coordinate plane. Prove that an angle is supplementary to both of us. That does not work on a coordinate plane. We can't do angle measures on a coordinate plane. Prove that both pairs of opposite angles are congruent. Can't do that on a coordinate plane. We can prove the diagonals bisect each other. That we can do on a coordinate plane. And finally, this last one. Prove that one pair of angles is congruent and parallel. That one can also be done on a coordinate plane. So these are the 4 that you'll be able to use. I'm going to give you a figure on a coordinate plane. I'm asking you to prove it's a parallelogram. You're going to have to be able to do the work and show it. And that wraps up our video for tonight.